This is kind of a caveat video to video 5.1. I'm going to be calling this one 5.1.1 just to be goofy. I wanted to explain the sud mini project solution that I came up with for this assignment so that everyone can kind of learn from it. So first off, we had to essentially implement a system where players would go from room to room. That's the first thing that I started with, is basically finishing my early implementation. This implementation I did in the span of about an hour and a half, so it's not incredibly elegant. Actually, it was probably more like an hour, but it's not incredibly elegant, but it definitely does do the trick. And as I showed you guys before, you can go ahead and run it, and you can do take towel. You can say go south. You can say go east. You can say drop towel. You can do pretty much everything you need to be able to do. The structure for this is basically already created for you, and you just need to fill in the gaps, and that's what I went ahead and did. So I started out basically thinking about, well, what do I actually need to do? I start out in sud.cs, where basically I'm typing things, and so go was the operative one that I started with, where basically we're saying, okay, off you go is printed to the screen, and then we're going to say myPlayer.get room, so that's the current room that the player's in, get the exit that points to the current noun's name. So each exit, each room has a list of exits, as we talked about before, which is a dictionary of strings to strings. And so when you say get exit in a particular direction, it sees if it has that key, and if it does, it returns the room. So that's going to return the room that goes in that direction, and then we're going to say get named room, and we do a set room, and set room basically is going to take a room, and it's going to say that my current room equals room parm. And so that's just going to go ahead and override the player's current room with the new room. And that's Go in a nutshell. So nothing too crazy there. I did add extra rooms. I ended up adding, north, south, east, and west room, which is the living room, kitchen, outside in the forest, as I talked about before. And each of these needs an exit. The north room needs an exit to the south that goes to the kitchen. The south room needs an exit to the north that goes to the living room. South room needs a exit to the east that goes outside. West goes to the forest in the south room. West goes to the kitchen in the east room, and east goes to the kitchen in the west room. So that ends up looking like something like the following, where you've basically got your north room, your south room, your east room, and your west room. And you can go back and forth between these as much as you want. So that's sort of how that looks. And I suppose I could even put goofy little arrows here just to be cool, I guess. You can go back and forth between the north and the south, the west and the south, and the south and the east. So that's basically all implemented in here. And the next thing I needed to do was I needed to add items to this, so I made a new function called beginning item loader. You'll notice that beginning item loader is called right after beginning room loader, and all it does is adds the 3 items that are in question to named rooms. So this does a get named room to get me the room object, and then we do add item on a new item object. So the room, I believe I modified this slightly as well, where I basically have an item, I do an add item, and I take in an item parm, and I say item.item name equals item parm.item name. This is a little bit cheesy. It wouldn't work once we get more than one item in a room or more than one item in an inventory, but I didn't want to deal with arrays for simplicity reasons, because we hadn't covered them yet in class by the time you guys started this assignment. So I just did it this way, where basically every room has an item in it, and that item starts out empty. So when you say new item here, that creates a new item that's empty, and we've got the constructor for item here that basically just gives me an empty string, which is basically just saying there's nothing there. So when room is created, it's created with an empty item that just means nothing. And so there's nothing there. I also created a helper function, which is what this is called hasItem, that basically checks if the item name is empty, then it basically returns false. It says that that room does not have an item. Otherwise, it returns true. And of course, returns true is only ever going to get hit if this is not equal to the empty string. Remove item is pretty easy because all you got to do is change the item name to be empty again. Likewise, there's a remove item in player that changes the item holding of the player to empty. Player also has a new item holding instance variable, which is always going to be present in the player. That's always going to be there. It's either going to be the empty string, or we're going to call set item on it, and that's going to set the item name equal to the item name that's incoming. One thing that I don't particularly like that I did with mine is you'll notice that entity, all of these are being derived from entity. We're covering inheritance this week. So I'll let you guys spot the inherent problem, no pun intended, of the way that I did it. It's the way I did it ends up being a bit ugly and kind of breaking inheritance. And I'm going to leave that for an exercise for you to figure out in one of your assignments, to tell me what you think is bad about one of the ways in which I implemented this in terms of the inheritance structure. So take a look specifically at the fact that entity is derived by item as well as player, as you can see here, as well as room, and that's about it, as well as world. So take a look at, see what you think is wrong, and I will tell you that it has to do with naming, variable naming specifically. And that will be one of your assignment items for this Unit 5. So anyway, that's about it. So as I said, it's not an incredibly pretty implementation. It's about an hour long that I spent on it just because I didn't have enough time to go into much greater detail. But it does the trick, and it sort of passes the satisfactory test on the rubric as I described before in the previous video. So if you have something similar to this, totally fine that it's a little bit messy, you can still pass the satisfactory mark on your rubrics and you should be just fine. So that's about it for this video, and I will see you next for the shooter. We're going to start with the space shooter again.